Welcome everybody to this summer school. We are very happy and very honored to have Dr. Rebecca Johnson with us today. She will be giving 6 lectures during these 3 days, and the topic is called Nuclear Weapons and Power, Current Challenges and Responses. Dr. Rebecca Johnson is the co-founder of the ICAN, the International Campaign to Abolish Nuclear Weapons, that got the 2017 Nobel Peace Prize. And she is also director of the Acronym Institute for Disarmament Diplomacy. So we are very, very happy that you are here with us, and we are very honored. So please take care.
Thank you. Thank you very much, Kin Chi. And I'd also like very much to thank Lingnan University for hosting me here, and the Global University for Sustainability. I think it's very important that we have universities not only in the cities and towns in our countries, but that we can link up globally. I think this is a wonderful initiative, and I'm so proud to and feel very honored to have been invited to present this series of lectures. So who am I? Well, I actually originally studied maths, physics and chemistry. I went to University of Bristol in the southwest of England to study physics. But I became an activist while I was there. And there were 2 things that triggered that. One was the coup against Chile. That was when I was just at university. And the coup that we now know, it was CIA backed, that brought Allende in, that ended up with the death of, that brought Pinochet in and ended up, General Pinochet, and ended up with the death of the democratically elected President Allende, ended up with the arrests and kidnapping and indeed murder of many, many civil society activists, teachers, students, musicians, people from the government. At that time, I also used to do singing, and one of my favorite people to listen to was Victor Jara, who was a Chilean folk singer and who was murdered. But also because there was a direct connection, because a lot of the refugees who managed to get away, who managed to escape over the first couple of years, and it was very difficult, but many of them ended up in Bristol. Bristol and London were probably the 2 cities in the UK that took most of the Chilean refugees. So we had quite a large community of Chilean refugees. So that was one of my, if you like, really influential political moments for my life. The second one of that was the growth of feminism. And actually, I began to learn about that during the year before I went to university, when I was lucky enough to be given a scholarship to go to, of all places, Alaska, and study there. And feminism was really just getting going in the US and the UK and some other countries, and also environmentalism. So again, these 2 things I kind of really got involved with in Alaska, where there was the resistance to the oil pipeline in 1973. This was also the time when President Nixon was actually forced to resign, and all that connection with the Vietnam War. It was just after that. And then feminism was in the growth, and I just learned so much, and I took that back into the university, and so I became involved in the women's liberation group of the university. So those were my backgrounds. And during protests at the university in my second year, I became a student leader of what was known as the nursery campaign. Now, why a nursery campaign? Well, because in physics, in my year, I was the only girl. And all of the teachers were men. And some of the teachers were loaned from the nuclear industry, but from the actual nuclear weapons laboratories at Aldermaston. And you will hear that name again. It is the major and original nuclear bomb factory in the UK. And I, even before the nursery campaign, I objected why I wanted to, I was studying physics. I wanted to do nuclear physics as part of this. But why were we getting lecturers coming from the nuclear weapons establishment? And the professor in, the head of department at that time said, "Oh, you silly girl, don't you realize that, nuclear, the weapons, the civil, it's all one technology?" And on one level, of course, I did recognize that. But I wanted to study nuclear physics in order to solve the problems of waste, nuclear waste. Because at that time, 1974, 75, I believed that nuclear could actually be cheap and safe and clean, or could actually be environmentally responsible. Because some of my first songs that I wrote as a schoolgirl in the 1960s were environmental. I didn't think of them like that, but I wrote songs about the acid rain from the nuclear coal fire, from not the nuclear, but the coal-fired power plants in Britain, ending up with acid rain depositing and killing trees across Europe. And I felt guilty about this. I felt responsible about this. I didn't protest about it then. I wrote songs. That's what I did then, poems and songs, as probably many of you also, because we all wrote songs and poems, didn't we, in our backgrounds. But so that's one of the reasons why I actually thought that learning nuclear physics could be important, because I wasn't sure, did I want to be a nuclear physicist and solve all the problems of waste? Or did I want to be an astronaut? Because another thing was that, of course, 1969 was the landing of the first human beings on the moon. And I found that whole idea very exciting, but also I wanted to keep space for peace. Am I going too fast? It's okay. So this tells you a little bit about me, because actually I ended up withdrawing from the physics department after this professor just made me think that if I wanted to study nuclear physics, I would have to contribute to nuclear weapons. And I did not want to contribute anything for nuclear weapons. But also the university put me on a charge for leading a peaceful demonstration in my second year to get a nursery campaign, to get a nursery established in the university that would provide nursery facilities, childcare facilities by the university, in the university. We even found a venue and were prepared to raise money for this, but we needed the university to agree, and eventually we wanted the university to take responsibility. Because if you had childcare arrangements, then it made it more possible for the teachers and also for students who had children, because not all students go to university at the age of 18. Many students go at a later stage, and for women, they may already have children. So the nursery was about opening education, but also opening jobs in education to more women. It was my first feminist campaign, and we occupied Senate House, which was the main administrative building of the University of Bristol. So this was my first political act of that kind. And a lot of us students did it, men and women. It was a big occupation, actually. It lasted for 3 or 4 days. So not quite as long as some of your occupations in more recent times. But for us, this was pretty big. And on an issue like calling for a nursery so that education could be open to women and to women, both students and faculty. So, but of the many that took part, only 4 students were taken to the university court and threatened with expulsion. And because of all the worry about all of that, and also because of that I had decided to give up for the physics, I said that I decided I had to leave the university. I was rescued by a philosophy professor. I had started going along to this professor's evening classes. I was still studying physics at the time, but it was in like philosophy, going sort of from Locke and the whole social contract ideas. Well, it actually went some from Aristotle and Plato, but I got very interested in Locke, and then we went to Marx and Engels and learned about the different ways of thinking about society. I hadn't looked at this. I had studied maths, physics, and chemistry as my priority subjects at school after the age of 15. And so this opened my eyes. And this philosophy lecturer, he said, no, don't leave the university. He said, I will try to get you into the philosophy department instead of the physics department. He said, because we don't have enough young women like you, and from a comprehensive school, which was this is the school that was for all the children. But most of the children in the 1960s and 70s who went to university went to something called a public school, which is not public. It is a private school. It is a school you have to pay for. And my parents could not pay for me. I'm the youngest of 8 children. So my parents could not pay for me to go to a private school. And I think actually they would not have wanted to. So I went to the local school from the age after my family moved back. I won't go into that history, but we had lived a number of years in the United States, in North Dakota and Pennsylvania, and I only really went to school in England at the age of 7. So for me, to have this professor say, we need more students like you, gave me more confident. I was really not feeling confident. And he helped, he became almost like my advocate with the university so that I would not be expelled and I would be allowed to study philosophy and politics. So in the end, my degree was philosophy and politics. So I learned a lot with that. But I also wanted to see the world. So I worked then for a year after that. After I got my degree in 1977, I actually worked as a labouring gardener in a beautiful park in central London called Regent's Park. And I did that because I wanted to just earn money so I could travel. I was offered to do a postgraduate, but at that time I just thought I need to see the world. And so I went traveling and I hitchhiked and took buses and trains. And anyway, I ended up in Japan for 2 years and working as a teacher there. The reason why I went to Japan is that one of my sisters had married an American. She had stayed in the United States when our family moved. She was 10 years older than me. She got married and they had 2 little girls. And I had always liked that sister and I wanted to spend some time. And the 2 little girls I had really bonded with when she had brought them to England to meet us, and their grandparents. So I went to Japan and I got a job as a teacher there. I'd already done a short course so that I could teach English as a foreign language. So I went to Japan, and after 2 years, I was offered another scholarship to do a master's degree at the University of London this time. But it was going to be on women's political participation in Japan. Because by this time, I had got involved with a group of women who were very politicized. They were feminist. They would teach me Japanese using texts in Feminism, and I would teach them English using English and US and Australian texts. And they also were being politically active against violence against women. They were some of the first to raise the issues of I hate this term, but the so-called comfort women. The women that during the occupations of China and also, and also this included Mongolia, not Mongolia, it included, of course, Korea and also Manchuria. And it was forced prostitution. And it was an act both of violence against the women and violence against the occupied people. Now, we know this happens in all kinds of war. But this group of Japanese and Korean women in Japan, Tokyo, that I became involved in, was quite a small group, actually. But they protested about that. They protested on the issue of what was called prostitution tourism. Now, we're talking about the years 1979 to 1981. That was the 2 years I was there. And at that time, groups of businessmen from different companies in Japan, one of the things they were actually forced to do as part of the company culture, many of the men didn't want to do this, and many of their wives really didn't want them to do this. They would go on a holiday for 4 or 5 days to places like Thailand and Malaysia and Philippines and Korea on what were basically prostitution tourism organized by and paid by their companies. And again, this was something that back there, 79 to 81, and of course, after I left Tokyo, my friends continued on these issues to protest and to build up kind of, argue for legislation to prohibit this kind of actions that were violence against women and violence against the peoples in the countries where they took these tours. And my group also set up the first ever rape crisis center in Tokyo for the women for the Japanese women, and then that spread. Now they did that 2 or 3 years after I had left, but again, this was part of my politics as a young woman. I did my year's study, I got my master's degree, but it was actually the master's degree I had to do a foundation course for a master's before I could do a PhD on the women's political participation in Japan. And my foundation course was very interesting because it had 3 components. It had Japanese politics of the 20th century, Chinese politics of the 20th century, and US-Soviet political engagement in Asia in the 20th century. So, and this was actually what I wrote my master's thesis on. But by that time, I had begun to be much more of an activist on nuclear weapons, because a women's peace camp was founded in 1981 at the Greenham Common US Air Force Base, nuclear base in England, located about 60 miles west of London, so really quite close to London. And in 1982, while I was still studying at SOAS, the University of London School of Oriental and African Studies, I started to visit Greenham Common. And after I did my exams, I was a good student, I did my exams. After I did my exams, I went, but before I had finished writing my master's thesis, I went down to Greenham Common. I actually arrived on my motorbike on the 9th of August, 1982. I had visited once before with some friends, but I went there to stay a few days. So I brought my tent and I arrived on Nagasaki Day, which it was a day that meant a lot to me. It was the commemoration of the bombing of Nagasaki. And I intended to stay 1 week. After 2 or 3 days, I just realized I had to make a bigger commitment, because the arguments that were going on among the women in the women's peace camp, arguments about non-violence, arguments about nuclear weapons, but about the environment, about the role of women, about patriarchy and, the whole oppression by toxic masculinity, and what we as individuals could do, personal responsibility, political responsibility, all of these arguments. Anyone who thinks, oh, but this was a group of women and a women's peace camp, it must have been really all nice, sweetness and light. Oh no, we had heavy arguments on all of these issues. Also on the use, on bringing alcohol or drugs or anything like that into our lives, into the campaign. This was all going on, and it was so exciting. So I went back to London, piled my books and my little typewriter. We didn't have laptops. I had a little typewriter, manual typewriter, and rode my motorbike back to Greenham, and I started to live there. And I thought, and during that time I was accepted for the PhD because of my exam results. And during that time, I thought, I'm just going to live here for a few months, maybe a few weeks, a few months. It ended up being 5 years. So and I did my master's thesis. I was already working on this subject, but being at Greenham focused my mind. My master's thesis was on US-Soviet rivalry over the occupation of Japan from 1945 to 51. So this was a very key time, because it was the transition from the Second World War into the Cold War. Some called it the Third War. It was a Cold War, not a hot war. But many times it could have turned into a hot war. And during that time, I studied closely. As part of my thesis, I looked at what was written about the dropping of the atomic weapons on Hiroshima and Nagasaki. And I became convinced, and this was the central argument in my thesis, and at this time, this was not very popular. I think there was one book, and I've put it actually on the reading list. There was one book that I could consult that had been written in, I think, the 1970s, maybe the late 1960s, by Gar Alperovitz, called Atomic Diplomacy. He was the first person to come up with a thesis that the nuclear weapons were not necessary to end the Second World War. Actually, they were the first weapons, and they were nuclear weapons. They were the first weapons of the US-Soviet Cold War. And I found his arguments very convincing, and then I looked at documents and I added my own arguments. So I just wanted, since we have the time and we have 6 lectures, I just wanted to start off by letting you know where my background is. So now I am going to move on to the PowerPoint and just give you a brief idea. So, as I say, you do not need to take the notes that you see on the PowerPoint, but you can, of course, take notes from what I talk about. So, really, I started this with Einstein. Now, in this first lecture, this is like the basics. So I'm going to go fairly quickly through some of these issues because the next 5 lectures are going to go into much more detail about nuclear weapons, is lecture 2. Then on the third lecture, we have presentations about Fukushima from colleagues who are coming from Japan, and I will make a much shorter lecture looking just more generally at the nuclear energy issues and say a bit more about the connection between, the nuclear energy generation, power generation, but also link it to the challenges, safety and proliferation. And I have a few slides at the end of that on Fukushima, which are quite recent, looking at the impacts. But then the 4th lecture I'm going to be doing is the one that's on, if you like, the realist or the establishment arguments for having nuclear weapons and also, in fact, for nuclear power spreads. These are the arguments around proliferation and deterrence and also the whole arms control. And so that's very much the kind of realist or neo-realist and, arms control, except that, of course, I take a very critical view of these issues. The 5th one, then, lecture 5, is when I start to bring some of these much more together, the issues, the intersectional issues, the issues of colonialism and gender. Because believe you me, nuclear weapons are a tool of colonialism and were a tool of colonialism going back right to the nuclear testing programs and nuclear production, uranium mining, all of these kinds of issues. Sorry, that's jumping up ahead. So, I'm giving a feminist analysis then of nuclear weapons and security, and this is something that a number of people are now developing. Of course, as you can see from my background, I've been developing for most of my life, sometimes very actively and sometimes more academically. And then the 5th one, I hope, is much more really an interaction between all of us, because it's about today's major challenges, both nuclear and climate, but it's where we can also bring in these issues of local local communities and contamination and environmental issues, communities looking for sustainability, movements for democracy and sustainability, and all of these kinds of issues, people's reactions and rebellions and movements. And we can talk a little bit more about how these develop and how they change, and look at the situation now. So we start with really just the basics on the nuclear age. And here you have, just some of these ideas, and it really goes back to Einstein, it goes back, of course, to splitting the atom. But we talk about Einstein, the Manhattan Project. The Trinity test was the first US nuclear test on the 16th of July. We go right through that. We look at the two bombs. We then go look at this thing called Atoms for Peace. I also, in later lectures, will look much more closely at the health and environmental, humanitarian impacts of nuclear weapons. Actually, I say a little bit about production, but mostly this looks from the use of nuclear weapons, the explosions of both nuclear testing and if nuclear weapons are used. Looking at the issues of radiation that goes through our generations, through genetic harm, that we now know particularly from Chernobyl and Fukushima and the nuclear testing programs. The nuclear use issue, the humanitarian and the nuclear winter, and a little bit about how the nuclear winter arguments played into the first real nuclear ban treaty, which was a regional nuclear ban treaty between the US and the Soviet Union in 1987. The Greenham Common, we think of it as the Greenham Common Treaty, the INF Treaty. But of course, the very original nuclear prohibition was enshrined in the Treaty of Tlatelolco, the Nuclear Free Zone Treaty of 1967. 1 year between the Non-Proliferation Treaty was a prohibition treaty, a regional prohibition treaty. But the INF Treaty was the first between the US and Soviet Union. So we look then at those, and finally I come to the 2017 Treaty on the Prohibition of Nuclear Weapons. So from Einstein we know this equation: energy equals mass times the squared speed of light. E equals mc squared. This is a fundamental equation of nuclear physics. And it also, of course, was a fundamental equation of the nuclear physics that led to the nuclear bombs. And Einstein understood this. But in the period where just before, when first Europe, and then it became a world war. First Europe went to the Second World War in 1939. Einstein was actually one of the people that wrote a letter warning then President Roosevelt that the US would need to find a way to develop nuclear weapons, because he was convinced that Germany had a nuclear weapons program. And indeed, there's still a lot of talk about this. We can talk about this ourselves. There's a brilliant play called Copenhagen that looks at this issue. Did Heisenberg, the key German physicist, was he part of a Nazi program to make nuclear weapons, or did he work within the German establishment, the Nazi establishment, to try to prevent Germany getting nuclear weapons? We don't know for sure, but it's a very interesting question. But this is really where I think we need to start. And then, of course, we need to go to the basics of the production. And production starts with the mining of the nuclear weapons. So it starts with the mining. And uranium, when it's in the ground, it is toxic. It has radioactivity, quite low level. It is a major health risk to the miners and people who handle it. But you can't make a nuclear bomb and you can't generate electricity out of the uranium you take from the ground. You have to, first of all, enrich the uranium. And what you do with that is, uranium has the isotope 238 and the isotope 235. Basically, it has a number of other things in it, but when you're connecting, when you're bringing out the yellow cake, as it's called, the actual uranium out of the ground, then what you have to do is convert it, enrich it. And to do that, you convert it to uranium hexafluoride, this UF6. You don't need to know all this detail, but just basic stuff is what you have to do is to change the composition so that you increase the amount of uranium-235 isotope relative to the uranium-238 isotope. Now, uranium-235 is the fissile. You'll hear us talk about fissile materials. It's the much more fissile. Now, usually I say 2 to 6% uranium enrichment is reactor grade. It can vary. It's usual, considered that it is below 4%. So when you hear about this restriction that was agreed by Iran at the time of the 2015 Joint Comprehensive Programme of Action, so-called Iran nuclear deal, that was a deal made with the United States and the UK and China and Russia and France and also Germany and also the European Union. Iran was required to agree to enrich I think it was 3.67. It was just below the 4%. This was considered legitimate for a nuclear energy program. Now, in addition to nuclear energy for power production, I should mention there is our reactors that make medical isotopes and isotopes for agricultural and other so-called other peaceful purposes. We have to separate those out. It's very small scale. You could have these reactors attached to universities for medical and research purposes and so on, but it's small scale. When I talk about atoms for peace, generally I am much more talking about the nuclear energy, large scale power production issues, but I'll come to that later. Now, the small scale research reactors sometimes will go up to 20%. But it's very, very small scale, the uranium enrichment. Also, certain countries like the UK and Russia and the US, they still use, and I'm not sure about China actually, you may be able to tell me, I need to look this up, but I don't think China does on this one. But they use a form that they call low enriched uranium, but it's not. It's a semi-high. It's uranium enriched to 20% in the naval reactors. So the nuclear reactors in the submarines, we call them the Trident submarines, but they're the submarines to carry the Trident nuclear weapons in the UK and the US. These have, the UK is building a new generation of reactors that use naval fuel that's enriched up to 20%. So this I am part of an international group that has about 20 participants, including from China and Korea and Japan and UK, France, US, Germany, a range of countries with, South Africa, with significant nuclear programs, whether for weapons or civil. It's called the International Panel on Fissile Materials, and it's based at Princeton University. You'll see we have some slides. It's called IPFM, International Panel on Fissile Materials. I'm part of that. I'm one of the members. And we are arguing that all high enriched uranium programs and all plutonium programs should plutonium production and plutonium reprocessing, which is a form of production, sometimes presented as a form that helps you manage waste, but we'll talk about that more on Wednesday. We argue that these programs should actually be prohibited, should be ended. That for the time being, as long as there are nuclear power production for energy, and as I say, we will talk more about this on Wednesday, but we argue that you only need uranium to be enriched no more than 4%. So we make that argument from a physics point of view first and foremost, as well as a policy point of view. Now, to make nuclear bombs, the uranium has to be enriched to about 90%. You need that level of enrichment so 90% has to be the uranium-235 isotope, because that's the one that has the chain reaction, the fissile reaction, the chain reaction that enables it to become a nuclear, for the explosion. Now, the little boy, so-called, the Americans dubbed the Hiroshima Bomb, Little Boy. I'll leave you to guess why. Relative to the size of the Nagasaki bomb, it was a much slimmer one. Why? Because it used uranium and it used a form of weapon called the gun type. The one used on Nagasaki was a plutonium bomb, and it used compression. And here are the two basic designs of atomic weapons. The gun type assembly, where you have your conventional high explosives at one end and they propel into the two hemispheres of the uranium-235. And actually the Hiroshima bomb was practically uranium metal. I mean, it was very high fissile content. The Nagasaki bomb, they had a central core of the plutonium, and they then surrounded that with a packed high explosive. And that was geared so that for detonation, when the bomb would land, that the detonation would happen equally all the way around this circular core of plutonium. And it would be instantaneous. It would compress the two halves of this core together. The core was, again, two halves, but it was slightly separated. So it would compress that instantaneously, and that would cause this explosive reaction, because that fissile reaction that makes nuclear bombs is very, very, very fast. Now, if we go back to this picture again, so we go from conversion, and only when it's this uranium hexafluoride gas can you then start doing enrichment. And gas centrifuge is one of the usual. There are a couple of other technologies you can use for centrifuge, but you know, the ones, for example, the ones in Iran, most enrichment has been done by gas centrifuge. And this is where they can enrich up as high as they want. And this is the problem, this is the proliferation problem. If you have the technology of gas centrifuge enrichment, it is just a matter of how many centrifuges you install and the length of time you spend as to whether you go to 4% and stop there, or you go to 90%. The technology and the enrichment process is exactly the same. So once you've installed those centrifuges, you can go to weapons grade. It's just a matter of money, time, and how many centrifuges. This is why the world is so anxious about the Iranian nuclear program, because Iran always says that it has only the desire to make its own enriched uranium and fuel for an energy program. And so far, by and large, that's actually what they've done, which is why the 2015 Iran nuclear deal was possible, because they haven't actually enriched up to 90%. So the point of that deal was to get agreement by cooperation, by treaty, by diplomacy with Iran, that they would agree to enrich to below the 4% and to have inspectors from the International Atomic Energy Agency, the IAEA, again we will talk later in more detail, to monitor that that's all they're doing. And I myself have visited Iran. I went to the Isfahan uranium conversion plant, and they were going to take us to one of the centrifuge plants, but this was back in 2006, I think it was. And in return for Iran agreeing through this treaty not to enrich higher than the 4%, and also to allow really very intrusive, very full and detailed inspections by external international agencies. Therefore, and this is the treaty that President Trump has withdrawn the US from as of last year. Completely crazy, and we will talk about this later, but this is where we are. And the problem then is, if there's no treaty, then Iran is not obliged. There is no agreement under the NPT about enrichment or reprocessing. The NPT does not mention enrichment or reprocessing. It does have its Article 4, which contains a provision saying that, in fact, as long as you accept the IAEA safeguards, which are required under the NPT in its Article 3, you're allowed to do enrichment and reprocessing. Japan, for example, has a very detailed, very full enrichment, reprocessing. They have virtually the whole nuclear fuel cycle. And indeed, Iran has continually said, we only want to do what Japan does in compliance with the NPT. And on the face of it, that is what they're doing. And in fact, they've agreed to an additional set of constraints that Japan has never been asked to agree. So we have to see how politics also comes into this. Why is Japan allowed to do these things and Iran is not? So these are all connected issues. And I'm taking time on this because This is the basics that you need to understand a bit how the physics connects with the politics, because we're then going to talk in much more detail more about the politics and the policy issues in the other lectures. So once you've enriched your uranium, oops, sorry, wrong way. Once you've enriched, you make fuel out of it. You make fuel rods. That's fuel fabrication. And most of the fuel rods are mainly uranium-based, but there are a few nuclear power plants that have been developed. They were particularly developed in the 1980s, 1990s, and they are connected also with reprocessing plants, because what they do is they produce plutonium. The reprocessing is actually basically a chemical process. It separates plutonium from used spent fuel rods. So it's often presented as if it is a form of recycling, sometimes even called by its advocates recycling. We don't call it that because I don't think it is recycling. But from your fuel, when you run your fuel in a reactor, whether it's a research reactor such as made the original the original plutonium for the Nagasaki bomb, then you then subject it to this other process in which you run the fuel, and you then can chemically separate out high levels of plutonium. And you can then make that into another type of fuel called MOX, mixed oxide fuel. Now again, this for a while was treated as a wonderful thing. And so it started to be used in some nuclear power plants. Actually, there are a lot of problems. We'll talk about that more on Wednesday. Oops, sorry, I keep moving the wrong thing. So the next thing, so we go to the reactor. And so you can either put the used fuel, often called spent fuel, into storage, or you can take it through, and this is this other arrow, you can take it into reprocessing, and then the reprocessing can go back, so that's easier for me, but go back up to MOX fuel. Now reprocessing is sometimes talked about as a means of managing waste, because the waste out of the reactor is voluminous. The volume of the waste is massive, and there's low level, there's medium level, and there's high level waste. And so if you've got these massive quantities, you have a space problem as well as a technical and problem with the waste. Now, one of the reasons that I wanted to study nuclear physics is waste is the back end. It's still a massive technical and very big environmental and therefore political problem associated with nuclear energy, because all nuclear energy produces waste. And the waste has a lot of problems. It's toxic, very toxic. It's very dangerous to human health. It's radioactive, with low-level radioactive, medium and high. But it also, it keeps on with, even though it's no longer being as useful for the fissile reaction for making nuclear energy. And here again, the fissile reaction for nuclear weapons is very fast. I said it's instantaneous. You can press it and it explodes. For nuclear energy, you have that much slower reaction. That's the whole point of keeping the fissile material at below 4%. I think, no, I think it's on, I have this, yeah, no, I think I have that slide is actually on Wednesdays that just shows you, but basically the reaction within a fuel rod within the nuclear energy core, within the nuclear power plant, it keeps a reaction that keeps on sustaining and keeps heating. It creates a heat reaction. That's why all power plants have to be cooled constantly. And if they are not cooled, as happened with 3 Mile Island and Chernobyl and then Fukushima, if something goes wrong and the cooling gets messed up, they just keep heating and heating and heating, and they basically have this thing called a meltdown. They melt. They keep heating until they melt. But waste carries on having a fissile reaction, just a very much slower fissile reaction. But a core problem of rad waste, of nuclear waste, is not just that it's radioactive, but that it carries on with essentially a warming reaction. So whatever you put it in, they got very keen on the idea of vitrification, which is encasing it in glass. And then they found that, you know, glass is also like it can liquefy. So they found that actually there was a problem, particularly at the higher levels of waste, by encasing it in glass, because the glass nearest it began to warm up just from the warming reaction of the waste. And then it began to become more porous, and then radioactivity could leak. So, and this, I have to tell you this, we have not all the genius of physicists and chemists in all of the states that have nuclear programs and the International Atomic Energy Agency. None of them have sufficiently solved the waste problem. It's still a problem that's unsolved. So reprocessing, I saw a hand, was that a hand or just a stretch? Maybe a stretch. So the reprocessing part of this was meant to be a way to manage the waste, because through reprocessing you end up having much smaller quantities of very high level waste. And then you still have the large quantities, but they are much, much lower level in terms of their radioactivity and in terms of their heating capacity. So that's why it was thought to be a solution. I think it's not a solution, but we can come to that later. So as you see coming from the reprocessing, you get the attempt to vitrify the high-level waste, to enclose it in glass, and then to dispose of it. But what do you mean by disposing? This is where you have these high-tech, deep underground storage facilities. Finland has a famous one that is like a prototype. It can only take small quantities so far, and it's deep in the Arctic. We're going to have to talk about that later. But that's where you do with that. And at the same time, the reprocessed uranium, which then becomes low level again, can go back into the conversion. So it's called a fuel cycle. Some of us prefer to call it a nuclear chain. And then the other thing that I didn't talk about is the tailings. Now, the kind of countries that had major amounts of uranium mining, countries like South Africa, when it was under apartheid, Rio Tinto zinc, and Namibia also had uranium mining that brought in a lot of money for South Africa, and they produced the plutonium that went in, for example, to UK and a number of other nuclear programs during apartheid. But they still do, those mines are still working. But they had, then Australia major uranium resources. Again, the British benefited from that, and Australia also sold for a lot of power plants and still sells. But these uranium mines are on Aboriginal people's lands. And there is an interesting reminder for us as humanity. The Aboriginal people had ancient, what were considered to be myths, but we could equally consider them to be lessons, teachings handed down from generation to generation. And when the British and the Australian governments wanted to mine uranium, the Aboriginal people said, you must not do that. They didn't know the name uranium. They said there is a rainbow serpent in these locations. And if you disturb the rainbow serpent, it will wake up and it will produce fire that will destroy the earth. And they were laughed at. And of course, British colonialism together, with Australian, all of this connected. Aboriginals were moved further away, but Aboriginal workers were used to do the uranium mining and still are the major workforce on uranium mining. The managers were all white, but the workforce was not all white. And the people who got hurt, the contamination, and they, of course, you should also know that Britain conducted plutonium nuclear tests on Aboriginal lands at places like Maralinga, but I talk about that more tomorrow. So, and then this mining creates this thing called tailings, which is like just basically rock. Like with coal mining, it produces kind of, or any kind of mining, there's tailings of some kind. But this tailings is contaminated, low level, but enough to cause real health and environmental harm to the people who live there. It contaminates the water supplies, it contaminates the growing of food, it contaminates the people, and it goes into the next generation. So it has really caused a lot of birth defects, a lot of harm. So at every stage of this nuclear technology chain, there is contamination for the people. So now I am going to pause there because I think we have time, and I think you've taken a lot of technical information in, and I would suggest we have like a 10-minute break here.